Today I want to talk to you about the Pythagorean theorem. The Pythagorean theorem says that if you have a right triangle, and a right triangle is a triangle with what? A right angle. If you have a right triangle, then the squares of the two sides added together will equal the square of the hypotenuse. So leg squared plus leg squared equals hypotenuse squared. That came from the fact that Pythagoras, who was kind of a nerdy dude for his time, you got to remember they didn't have TV back then, so all they really had to do is math. He noticed that when you measured the area of a square of one side of a triangle, and you made another side of a triangle into a square and you measured its area, that area was exactly the same as the square of the side that was the third side, the hypotenuse. All right, so in a situation where you have a right triangle and the Pythagorean theorem applies, we've noticed that there's patterns of numbers that were sides of a triangle that make a right triangle. So for example, if I took 3 and I squared it, and I added it to 4, which was squared, that would equal 5 squared. Because 9 plus 16 is equal to 25 is a true statement. So since those 3 sides make up a right triangle, we've grouped these as Pythagorean triples. So if you have 3 integers and the sides of those integers make a right triangle, that's a Pythagorean triple. So it might be worth it to you to make some note cards if you're like to save time, especially on standardized tests such as the ACT, and you want to recognize if things are right triangles really quickly, to memorize these very, very common Pythagorean triples. 3, 4, 5, 5, 12, 13, 8, 15, 17. That was the one that I always forgot about. And then 7, 24, 25. Seeing those will really quickly let you know that something's a Pythagorean triple. I mean, you could always work it out and figure out for sure if it was, but not having to do all of this and say, oh yeah, that's a right triangle, might be a time saver. So, showing you how to do this type of problem. When the length of the hypotenuse, find the length of the hypotenuse of this triangle, and then after I'm done, decide if I have a Pythagorean triple or not. I'll have a Pythagorean triple if all 3 of the numbers that were involved in the triangle are integers. So in other words, if I end up with a perfect square for c squared, I've got a Pythagorean triple. So here's how I would work this problem. I would start out by taking my 2 legs, 20 and 21, squaring them and adding them together, and setting it up to be the length of AB squared, which I'm going to call C. So that's 400 plus 441 is equal to C squared. So that's 841, which is equal to C squared. And when I take the square root of both sides, if you do that on your calculator, and you actually end up taking the square root of both sides, then you find that C is equal to 29. So what did I do? I just took this formula, plugged, chugged, and solved. 29 is an integer, so I would then say 20, 21, and 29 are a Pythagorean triple. We call it a Pyth trip.
Do you do it by this shortest amount to the largest amount when you write it?
It doesn't matter what order you put the legs in. The hypotenuse always will be the biggest number. Oh, and when I write the triple, do I write it in ascending order? Usually I do, yes. All right. So what I want you to do is I want you to take this information. The legs of a right triangle have lengths 10 and 24. Find the length of the hypotenuse. After you find the hypotenuse, I want you to tell me if it's a Pythagorean triple. All right. Tayana, how did we set it up?
10 square plus 24 equals C squared. work it out, and we get 100 plus 576 equals c squared, and we'll get 676 equals c squared, and then find the square root of 676 and square root of 26.
Oh, so it's a perfect square. Sweet. Everybody okay with that? Pythagorean triple, yes or no?
Yes.
Yes. Pythagorean triple, yes, because 10, 24, and 26 are all integers. All right. Now, you don't always have to have the hypotenuse missing to use the Pythagorean theorem. So like I've always said, write your formula down, plug in what you know, find what you don't. So in this case, I'm missing the value of a leg. Well, the leg is leg squared plus leg squared equals hypotenuse squared, right? A squared plus b squared equals c squared. Does it matter if I put the 8 squared here or the 8 squared here and the x squared here? Does it matter which order I write them? Why not? So what property says it's okay to add numbers that a plus b is the same thing as b plus a? If a plus b, then b plus a. Neither one of those. Symmetric. Symmetric property of addition says it doesn't matter. Is subtraction symmetric?
No.
No. So everything isn't symmetric, but addition sure is. All right. So x squared will stay x squared. 8 squared will become 64. And 20 squared will become 400. Ooh, that got big quick. And then if I subtract 64 from both sides, 400 minus 64 is 336. And then to solve this, I need to take the square root of both sides. So x will become the square root of 336. Do we think 336 is simplified? No. So here's where we get that practice for simplifying radicals. I'm going to take 336 and I'm going to prime factor it. I know that 2 will go into it. 2 goes into 3 one time, 1 left over. 2 goes into 13 6 times, 1 left over. 2 goes into 16 8 times.
So is that like something you wouldn't let us use our calculator on?
You should not need to use your calculator on this. 2 will go into 16 or 168 84 times. 2 will go into 84 42 times. 2 will go into 42 21 times. Well, 21 is not prime, but 2 won't go anymore, so I go up to the next prime number, which is 3. 3 goes into 21 7 times, and 7 is prime. So what are my pairs? Well, I got a pair of 2s. I got another pair of 2s. Remember, a pair is when you have two numbers that are exactly the same. So is 3 and 7 a pair? No, because they're not the same. So what's 2 times 2 times 2 times 2? And what's 3 times 7? What's square root of 16? So it's 4 root 21. So that was the length of the leg. So remember, when you have the hypotenuse, make sure you put the hypotenuse value in for C. C is always the hypotenuse. Does that make sense? All right. Here's one for you guys to do if you need to. Sketch the triangle out, but you don't have to. Put it into the Pythagorean theorem and solve for the missing leg. Wesley, how'd you set this one up?
I put x squared plus 6 squared.
Excellent. Did everybody set it up like this where they put the 12 on the other side? A common mistake that I see people make is they always put the two numbers with the plus. But in this case, you had the hypotenuse, so it goes over here. So that's x squared plus 36 equal 144. X squared is equal to 108. And then x is equal to the square root of 108, which probably needs to be simplified. So how does that simplify? 6 root 3? So 108, I'll prime factor 2, 54, 2, 27. I'm done with the 2's. 3, 9, 3, and 3. So we have a pair of 2's and a pair of 3's. 2 times 2 times 3 times 3, that's 36. I'm left over with a 3. Square root of 36 is 6 root 3.
So is this a review? Is this still a review, or is this a review?
I mean, this is section 1. And I mean, even the review stuff could be on the test. All right. So here we're going to get a little bit more technical, and we're going to try to go for accurate information. So dog agility courses contain a seesaw obstacle as shown below to the nearest inch. So now I don't want a radical exact thing. I want to round it off to the nearest inch. So now I'm going to change my calculator back out of the math print mode and into the classic mode so I can get a decimal when I take a square root. And I'm going to solve the following problem. So do I have the hypotenuse? Yeah, it was 36. And so that's going to be leg squared plus other leg squared equal hypotenuse squared. And these are all in inches. So that's x squared plus 26 squared is 676. 36 squared is 1292. I'm sorry, 1296. Accuracy is important. And then 1296 minus 676 is 620. And so x is equal to the square root of 620. And now I just want to put that in my calculator and round it off to the nearest whole number. So the square root of 620 is equal to 24.8. That'll round off to 25 inches. So that's really not equal. That's an approximation. Does that make sense? All right, got one for you to do. Surprisingly enough, in TVs, they measure the TV by the diagonal. And so the diagonal would be a hypotenuse. So I tell you that the diagonal is 19 and the height is 11. You tell me the width. Round it to the nearest tenth of an inch. That's 1 decimal place. All right, let's see where we are at this. What was the setup?
I said a squared plus 11 squared is 19 squared.
Is everybody okay with that? All right, if you weren't able to set it up, I need to make a better A than that. If you weren't able to set it up this way, go ahead and reset it up this way and then see where you can get. All right, did you get 121 for 11 squared? And did you get 361 for 19 squared? And then when you subtracted the 2, did you get 240? So a squared is 240. A will equal the square root of 240. So a is going to approximately equal, if I round off to the nearest tenth, 15.5. It'll be 15.5 inches. All right, last thing I want to talk to you about. The converse of the Pythagorean theorem is also true. So I know I told you that if you had a right triangle, a squared plus b squared equals c squared. Well, if you know that a squared plus b squared equals c squared, then you absolutely know you have a right triangle. In addition, we can extend that to if they're not equal, what type of triangle would they make? An obtuse or an acute? So remember, there's 3 ways to classify a triangle by its angles: right, acute, obtuse. If you think about it, it makes sense. The longer the hypotenuse is, the wider this angle has to be. So the longer the C is, the bigger the C is, the more likely you have a wide angle, which is obtuse. The smaller that C is, the more likely you have a narrower angle, which is acute. So when C is bigger than the sum of the other two, when you're talking about their squares, you'll have an obtuse. And when C is smaller than the sum of the other two, you'll have acute. So what do I expect you guys to be able to do? Well, I expect you to be able to tell me if a triangle is acute, obtuse, or right. So in this particular one right here, I would look at 6 squared plus 11 squared. The smaller two numbers are always A and B, and compare that against 14 squared. Now you don't add them first and then square it. You square them first and then add. So 36 plus 121 comes out to be 157. 14 squared comes out to be 196. So the hypotenuse thing was bigger than the other two things. If you think about it, that means you probably had a really wide angle there. So since the hypotenuse is bigger, this one was obtuse. If these had been equal, it would have been right. And if this had been bigger, it would have been acute. Does that make sense? All right, one for you to do. Tell me really quick. Is a triangle with lengths 7, 8, and 9 acute, obtuse, or right? All right, so this one comes out to be acute because when I take 7 squared plus 8 squared and compare that with 9 squared, that's 49 plus 64, which is 113, and that's bigger than 81. So since 113 is bigger than 81, we have the leg squared stuff bigger than the hypotenuse, and so that's acute. All right, there's your homework, and be successful.